Good afternoon, dear professors, research scholars, and all the attendees. Myself, Dr. Suganya from VIT Chennai. Today, the topic that I have chosen for discussion is just a discussion. So, I am going to talk on my perspective of how the data set, which is of very important today, that is COVID-19, can be analyzed using the Python. Because I have understood that the course is entirely about Python, and hence, in order to make it a more clear perspective that and to give a very clear perspective on the importance and the availability of the different kind of solutions in Python, I took this as my topic. So before getting into that, this is going to be the agenda of my presentation today. So we'll shortly discuss on what machine learning is without taking much of the time, and we'll go for the prerequisite that is required for you to proceed with, and then we'll look at the different packages that are required for the machine learning to be done. Okay, and then we will go for the exploration of just have a look at the important tools that is required for the Python machine learning implementation using Python, which is Jupyter and Google Colab. And finally, the most important concept, I just have taken a public repository which government has shared, that is COVID-19 dataset with the patient history, and I'll show you how we have worked on it, just arriving at the probability of how much infection, that is the probability of person being infected with the corona disease. So this is going to be the agenda of my presentation. So shortly I'll take some 5 to 10 minutes in going for a discussion, and then I'll move on to the data set. So this is the trending topics for today. So it is about, all is about AI, ML and deep learning. So just my own point of view in just going to this. So what is machine learning and deep learning? Artificial intelligence, let us come later. So machine learning, it is something like a concept which exists for a very longer time, right? So this is not anything completely new. Whatever topics that we are using in our day-to-day life, it has been brought in with some adjustments over a very large data set, and that's what we call it as machine learning, right? So you can just in order to understand the difference between machine learning and deep learning, it could be something of this kind also. Machine learning is something where we need to execute a data set with a representative algorithm, and we have to find out whether the accuracy is up to the mark or not. Okay, because up to the mark, we say it is not equal to all of them. So somebody is in need of more accurate answers like 99.9, but if I am a slow learner, I can go with 90% result. So that is what machine learning does. So we take the output from a particular learning algorithm. We see whether it is acceptable to our requirement. If it is okay, we'll stop at this point. Otherwise, we'll go back, changing the parameters, and then we'll do. Okay. So it is like every time when I see, when I give a work to my student, okay, I'll just check by the end of the corresponding assignment, I'll check whether his progress is correct. If not, I'll train him with something else. Again, I'll ask him to redo the exercise, and this will go on until I get satisfied with the student's performance, right? So coming to deep learning, so most of the time this is becoming a hectic exercise, right? So if I'm having so many number of students which I can't do it manually now, I may appoint a particular person, let's say a person below me, to take care of my students. Okay, so what is the duty? That particular person can go train the system n number of times, find out whether it is correct or not, change the parameters for them, adapt the strategy of how the student will like. All those things that particular person will take care, and finally at the end what I am going to get is only the required output which I have stated earlier. Okay, so that is how I perceive deep learning to be. So it is on top of machine learning, so which can run of its own, trying to compute, okay, trying to identify the problems in the data set and the problems in the learning algorithm, improvise it using the parameters what we call as your hyperparameters, come out with a perfect solution. So that is how deep learning sits in midst of your machine learning, right? Okay, now what is interested? See, we don't bother whether I am giving the training to my student, whether my subordinate is giving training to the student. What is expected is a presentation, right? How am I going to present my student before a placement committee is what is required. So that way we have artificial intelligence coming into practice, right? So this artificial intelligence sits on top of either your machine learning or your deep learning, acts as a wrapper, trying to provide a better presentation to the clients, right? Now all that actually I done my PG and PhD both in software engineering, and hence more interested towards the business perspective, right? So what the clients will be interested in is not the accuracy or any kind of score that we are in need of, rather they are interested only in the information which you are going to give out. Okay, so how that information comes out, it won't never be using your machine learning or deep learning by the application of your AI. Okay, so that's how this is my own perception. The perception differs from person to person, right? Some of the applications, all those you would have seen, just for a refresher I have given. So any domain you take, be it the healthcare or anything, okay, that the nowadays entire in world is running to behind the machine learning and the deep learning algorithm to understand how this pandemic happened. Okay, and hence any domain we name, the requirement of machine learning and deep learning is obviously there. Okay, so then now what is required? We need data, obviously, right? So where is the data? It is everywhere. We can't say that this is the data, that is the data, this may be required, that may not be required, right? Each and everything we are trying to store, and we say it is a data. Okay, so who is generating the data? It's everything and everyone. It's not only the human being that is generating, as you would have discussed, Geeta ma'am would have discussed and Sublakshmi ma'am would have discussed on today. So the data is anything and everything generated by you, me, and everybody and anything, right? It's not only the human. Sensors are generating so many data, which is the most important and the relevant data for today. Okay, so now that you today the talk for the today is about this COVID-19 data set. So how are we going to get the data about it? Okay, so the basic data is what I have given here. How do you identify whether the person is infected with COVID, that is coronavirus, or not? Okay, so government has laid out some of the symptoms. One is the presence of fever, how many times a person is coughing for a minute, and whether the breathing problem is there, and whether the tiredness is there with the person, muscle ache, and so many other things. I have taken only the prominent things. See, actually I am talking only for as a simulation, not in perspective of research. Okay, and hence whether these things, how can you measure all these parameters? So fever could be measured by a value, the temperature. Cough, the it's a frequency, right? So, and problem in breathing, yes or no, you can get from a patient, or else if there is any measuring parameter, we can measure. So nothing is of difference. So this particular measuring unit is what we call as the unit of measurement, which we need to be very much careful. Okay, so whether these attributes are enough, not at all. So who has generated, who is having these kind of details is also to be recorded. So okay, so what we require, patient's name, address, history, and so many other details. Okay, so how one came at this set of attributes? It's through our own experience, right? So initially when we set up a domain of interest, so based on the domain, we'll try to give the set of attributes for which we need to store the details. But as days progress and based on the experience, this attribute set will increase. Okay, and hence after 10% came in, we may understand the probability of having person infected with this particular disease may be more in with diabetes patient. Okay, and hence a column or an attribute of having whether the person is already have a history of diabetes is already stored or not. Likewise, your attributes will be added, and hence you will arrive at a data set of this kind. Okay, so as ma'am also pointed out, be it your image data or textual data or numeric data or anything you take, finally it will end up with an Excel sheet of this kind. Even if you take unstructured data, some or other operations we need to perform on the unstructured data, and hence we should arrive at only this an Excel of this kind, right? So how does this look like? We know it is on this matrix format, but above that, my own perspective is to look at this as a relational DB, right? So what is a relational DB? We will have a table where we have a set of columns, and individual rows we call it as tuples, okay, or entities correspond to every value. Okay, so now that all the attributes that we have taken forms the columns or the attributes, and P1 to Pn forms your patient history. So what are all the values patient 1 is having, 2 is having. Okay, all those things we can store data in this format. This structure is not restricted. You can add on anything. Right. So now what to do with this data? Okay, now that I have understood that I am in need of data, I have formulated my attribute, and with that I have stored all the data that I have received. Okay, what to do with this data? Whether the data alone is enough? Not at all, right? So this data has to be converted into an information. Okay, only then it is of use to it will add a business value, right? So what is that information? The processed data, anything that you are going to get from the data set after processing is what we call as your information. Okay, something what I have written is the number of patients in a particular area, right? Now we have the app which can tell you how many number of patients are around us. That is one information. Okay, if it states that these are all the areas where people are there, it will be of not much of use. Okay, rather when I say that I am here, if it tells you within how many kilometers of circle a patient is there, then it's of more use. Okay, so that becomes your intelligent information that you can retrieve from your data. Okay, and how much is the probability of having this virus infection when fever value is very high, when you have too much of fever? That too much is what is the threshold value that people set. Okay, I can say 1 or 2 as a very high value, but to them 105 degree might be of higher value. It depends, right? And hence only if you can convert this information into that is data into an information, we say that we have given a business value to a client. Okay, some more sample information. So this is all is the outcome of the research. We look at the data set. So all of us, it's like no data set will be given to us, and how you perceive at the data set, how I perceive at the data set, that's the difference in our research perspective. Otherwise, that is, these are all the different type of outputs that one could end up with. Okay, so this is what I have given. That's it. Why machine learning for this data set? The next important question, right? So it's after all data in a relational database. Why can't I solve using normal SQL queries or a statistical formula or a very minimal statistical analysis, right? Why machine learning? This is a very important question. Why to use machine learning when you are given with the data set, right? So first thing is, when the size of the data set is very large, okay, which a human being can't process. Okay, so that is when we move on for machine learning. And when you find variability in the data set is too high, okay, because statistical formula, if you take, it requires some kind of distribution, right? So it should be in a normal distribution, Z distribution, Poisson distribution, some kind of distribution it may expect for we to get adapted to that particular formula, right? So how do we process if the variability in the data is more and doesn't fit onto any of those corresponding criteria? That's where machine learning comes into practice. And what is the type of information you need? That is more important, right? Not everything can be calculated manually or by using statistical computation. So what kind of information you need? So depending on that, you can decide whether we to go for machine learning or not. And use of manpower. See, with this much of computational processing speed and this much of resources, it's always obsolete to use human manpower for this kind of information, and hence machine learning could be of use. Okay, and this is more important. We are not interested in exact match of tuple, right? So if a new patient, not a patient, if a new person is coming with a kind of symptom, okay, and if we are interested in identifying the probability of the presence of corona for that particular patient, okay, so we are not interested in having an exact match. Okay, we are not here to write a query, select a star for this infect probability from this data set where this value, so that is not required. Okay, instead we are in need to have a complete mapping over the data set to find out what kind of output or the probability the patient is going to have. That comes out of machine learning rather than your relational database or statistical approach. Okay, so that's where machine learning stands distinct. Okay, and this we have seen. And coming to structured data, you can have any number of type of data formats that you can store. Number, both integer as well as floating point, string stored as an object, boolean values you can have store true or false, date you can store, images you can store, and none is another object you can store. And if you are not storing anything, a special value called NaN, not a number, will be automatically be stored, because when one of your attribute is diabetes, okay, some persons doesn't know whether they have diabetic or not, in which case that column will go empty. That emptiness is given in Python by means of NaN. Okay, so as and when this data formats gets increased, your algorithms are evolving. Okay, some algorithm require all the data to be only in numeric format. When you are enforcing string should also be part of the data set, the next algorithm evolve, and hence there is always a evolution in the class of algorithms, right? So accordingly you have what are the type of data that we can have in your data set. So we have only two categories. The previous slide shows the data types, and this is the kinds of data. One, if you look at an attribute, okay, what are the kinds of value that you can have? One is continuous, second one is categorical. Continuous in the sense, if you look at your feature set, a simple layman example I'll tell you. In an Excel sheet, filter out the corresponding column. If it gives you n number of values which you cannot count, then we say the value is continuous. Okay, so it's for a layman understanding. So it is something like when you automatically go, that is calculate the range of the values rather than the number of values, we say it is continuous. The other case is categorical, wherein if you filter out, if you stay with only a finite number of values, let's say on the gender column you have male, female and one more other, then we say it is categorical. Okay, so accordingly you have binary or multi-class problem. So this is with this I'll close and we'll move on for the execution of the data set. So these are the types of algorithms in general. On a broader perspective, machine learning supports supervised and unsupervised. Supervised, this is with teacher. Okay, now there are coordinators for this event. They are monitoring, okay, how is it happening. So they will tell me whether the session is going fine or is it going bored. Okay, so those are the outputs. So this is supervised. So you have set of inputs. Finally, you have an output column. With that output only, we will try to figure out the informations, right? So that is supervised. Unsupervised in the sense I am opening and no one is going to bother who is staying online and who is talking. Finally, what we can gather is a group of people who is listening to the lecture talk to themselves, find out whether it is good or bored. Okay, so that is what we call as unsupervised learning. And in supervised, we can say we can go for regression and classification. Classification for categorical output, regression for continuous output. Unsupervised, nothing is possible because there is no output. Only you can group among yourself based on your own area of interest. Okay, so our intention is not to deal with that. Just give me a minute. I'll switch my screen to the Excel sheet. Ma'am, can you able to see an Excel sheet?
Yes, ma'am. Yes.
Okay.
Perfect. You can, it is visible.
Okay. 1 minute. I'll just. Okay. So this is one sample data set which we have downloaded with respect to this COVID-19. It's a public data set which you can download when you go to all government repositories, and Kaggle also is running a competition on this. So on top we can see the different attributes that they have given. The people ID, so it is just a running sequence number, gender, whether they are married, whether they have kids, occupation, public transport, how they come to the hospital, okay, and how many cases on the in the family that they have given, and how many deaths has happened. Okay, these are some of the terms. Comorbidity, it means with what are all the disease history the person is having, the age, and so many other parameters. I guess around 25 parameters they have given. Insurance, whether they have, salary, and then all those stuff for that. Finally, if you look at this Y column, okay, so it is the infection probability, infect underscore probability, infection probability, right? So given all these values, okay, taken out of a blood report or a blood test report, so they have already given the probability, they have already calculated the probability of the person being infected with the coronavirus or not. Okay, so this threshold, actually if you look at, as I told you, when I filter this, we cannot restrict on we cannot strictly say how many number of finite. Even if this is finite, Actually, it is infinite as the data set grows, okay, and hence the value will be continuous, considered to be continuous, right? So, when to say, based on this probability, you may say whether the person is infected with that is corona or not, depending on any threshold. Let's say if the infection probability is 75%, you can say that he is infected with corona or not. That is a different case. Okay, now that we are going to see, since these are all continuous values, what is the, whether it is a supervised data set or not? Yes, it is supervised because you have an output column, right? This infect probability is being calculated as a result of all the values that you are giving, that you are getting from the blood test report, okay, and hence this is an output. When there is an output, we say it is supervised learning. So once it is decided, whether classification or regression can be decided based on the type of value, okay. So this is continuous value and hence regression could be of interest, right? So now that I have done a simple analysis. Hello. So with that, we will move on for this data set. I have shown you the trained data set. Okay. So what I did is I just have read that data set, okay, into a frame called DF. Okay. So what is this data frame? It is the a component of pandas library. Okay. So pandas is a specific library which is used to create data frames. Data frames is nothing but a matrix. That's all. Okay. In layman terms, it is just a matrix. Whatever operation you want to do with the matrix, assume that as a relational database. Everything is possible in pandas. Okay. And I just have printed the shape of it. So its shape is getting printed as 10,714, which means 10,714 patients history is available. And then how many columns are there? You can see it is 25, right? So how to list out what are the columns? It is df.columns, very simple. It is showing all the headers that are available in the Excel sheet. Okay. So these are the 25 columns that is available on my Excel sheet. So with that, I am trying to print the first 5 rows of the data set, df.head of, very simple. So it is giving me all the values that are available here, okay, and hence this describe, okay. So there are two ways of using it. So if you use describe in this way, it will give you the value, okay. If you use it as a function, you can see it is calculating, like you can see how many number of values that are present on each and every attribute. There is a difference, you could see 10,714, here it is 10,403, meaning that there are some missing values in this part, okay. Some of the columns are values are empty and hence we need to pre-process it before proceeding for any kind of modeling, okay. And what is the mean, what is the standard deviation, what is the minimum value it is having, what is the maximum value it is having, and this 25, 50, 75 are all how much is the, how many datas are there that are running with 25% mean, okay, 50% mean, 75% mean. So this is used for statistical analysis. So it all is being achieved using a single command called describe, okay. So with that, now since it is a continuous value, today I am using linear regression as my machine learning model, and hence for a linear regression to be performed, we need to understand whether there exists any kind of linearity between your input attributes and your output attribute, okay. So how to know that linearity? It is through by statistically we can compute correlation and identify, or visually you want to see, you can draw scatter plot and see whether it is able to come out as a straight line, okay. When all those points are scattered, so that you can form a straight line, we say there exists linearity, or else you'll say it comes under non-linear form. So today I have used correlation. So that DataFrame.corr simply calculates the correlation between all your attributes. Now you see. Okay, now, so I have printed, okay, the number of columns that present in correlation. Actually, how many columns are there in our data set? It was 25, right? Now, when I print the length, it is showing only 18. Why? I want to know the difference, okay, which are all the columns that has not been taken into correlation calculation is what I'm interested with. Okay, because it may have categorical value, not the numerical value. Correlation can be calculated only with the numerical values. Okay, so what I did is I just have created a set out of the columns and out of this correlation columns also. From the two data frames, I'm creating set so that I can apply a set difference operator. That's it. Okay, and hence when I print, these are the columns. Okay, so 25 minus 18, these are the 7 columns which is not taken for correlation coefficient. So we need to first understand whether they are required for linear processing the linear regression or not. Okay, so you look at married status, gender, mode of transport, and the occupation. Okay, all the 4 if I see. Okay, so to our understanding, other in correspondence to other parameters, it is not going to add too much of value to say whether the person is infected or not. So and hence I have dropped. Okay, but this is all your own understanding. If you feel like the mode of transport may be one of the important parameter, you can add it and you can encode it using one hot encoding, which we'll see shortly. Right, so once dropped, now I am printing the length of columns. It is 21. Right, now from 25 we have dropped 4 columns and hence it is 21 now. I haven't executed this, I'll just execute. Yeah, now it is 21. Right, now with this again I went back to the data set trying to find out what and all may not be interested in, even though they are numeric. I found 3 columns: salary, which is not an issue for infection probability; insurance is not an issue for probably this infection probability calculation; and how many children you have, that also is not going to add. Okay, so these are all come through experience, right? So this dropping of columns, this principal component analysis, yes, you can do using the concept feature reduction, feature selection mechanisms. Before that, you can apply your own experience and this kind of strategies also to understand whether the columns are required or not. Okay, so having done that, now I am dropping these 3. Now if we print, see, you have 18 columns, right? So with this 18 columns, again we'll try to do the correlation, right? So once having done the correlation, again we see there are some mismatch. Okay, so in order to find out which is creating your mismatch, I am just doing this analysis again. Okay, which we have already done. So what I am doing here, to the parent data frame and with the correlation data frame, I am creating a set. I am applying the set difference operator to find out which of the columns are not being taken into account for correlation calculation. That's all. Okay, now why these are not taken into account? Okay, because they have categorical values. Okay, so now our next duty is to that is apply one hot encoding to change these categorical values to numerical values for further processing. Right, for that what I did is I have calculated what are the unique values that everything is having, like pulmonary score, this comorbidity column, and cardiological pressure. I just have printed only one, you can see. So these are the values that it has. Okay, so with this we are just writing a target class. So what I am doing is, this pulmonary score has these 4 values. Okay, score may be less than 400, 100, 300 or 200. So I'm going to assign one number for each one of that. Okay, so when I replace this column with this target class, wherever there is a value like less than 400, it will get replaced with 0. That's all, very simple. Okay, when I execute this, you can see the output. I'm just printing the first 5 rows. See, this pulmonary score, you can see instead of less than 400, less than 300 and all, it is 0, 1, 2. Okay, now that the other 2 remains same, comorbidity, and one more is your cardiological pressure. Now we will do that. Okay, again the same is what I have done. Again this hypertension, diabetes, none. Okay, so none is also one class. None is not equivalent to an empty score, and hence I am taking it as a class. Okay, so none is not none is shows an empty value. The person may not have hypertension and hence, or any kind of disease, and hence they may be noted. If a person is not able to understand whether he is having a disease or not, that comes under not a number value. Okay, and hence that should not be misinterpreted. You can see the comorbidity gets changed to appropriate values. And the cardiological pressure also, you see normal has been changed to 0, stage 2 elevated, and stage 3. So that is, sorry, stage 1. All those things we have done, and finally we end up with the completely numerical data set, right? So with this, if we identify the correlation, we can see almost for all the columns the correlation values have been identified. Okay, now the data set is some 25% ready for processing. Okay, now if I execute the same difference, okay, between these two sets, it's an empty set which shows all the values are converted to numeric without any further confusion, and hence it is ready for processing. Okay, now this correlation value, now I am trying to draw a heat map, okay, for this correlation value. Normally heat maps won't be of this kind, so I'll just show you. I'll just comment this. I'll just try to draw a heat map with the correlation matrix. It will take a minute to process and give you the graphical output. So yeah, you can see here. So the correlation heat map will be of this kind. Okay, I changed the color and hence it is looking like this. Otherwise, by default, it will come in white, black, and then red. That is in combination of reds. Okay, so it is a symmetric matrix having diagonal state as 1. It's just a representation of the correlation. Heat map will tell you the distribution of different values. Okay, so everywhere when you see the value, that is if the values are ranging between 0 and 1, white will represent 1 and then 0 will represent your black. So that's how it is. Now instead of since it is symmetric, there is no point in finding out, okay, whether x is correlated with y and again y is correlated with x. Okay, and hence I have just taken out only the upper half of it, and hence this half diagram came in. Okay. So we are interested in only upper half of the data, because again this is going to be the portion that is there available here. Okay, so with this what can we do? Okay, when the diagram is, when we are interested only in one column, for example, if I am interested in infection probability alone, okay, so how is it going to directly affect with the linearity of other classes can be understood by this heat map. Okay, so once done that, right, now I'm trying to find out how much is the minimal correlation value and how much is the maximum correlation value. Okay, so I just have printed and I could able to see the minimum correlation is with age, okay, of infect probability, and the maximum is with the people ID, because it is clearly understood that people ID is just a sequential number. Okay, when it runs to 1, 2, 3, there is obviously exists a correlation between that, because it is increasing. None of the value will increase like a sequential number. Now what I understood is we have to drop it, right? Is it or not? So this is not an actual parameter which we need to take out or consider for execution, and hence I have dropped. Okay, I just have commented, because once having dropped, if you rerun it, it will give you an error. Okay, so now I have dropped that column, and hence the number of columns gets reduced by 17. Okay, now you can see, and with this 17, now next duty is to find whether there are any null values or not. So the null values is being can be understood by using a simple operation called is null of dot sum of. Sum of will tell you how many null values are there in your data set. You can see there are a lot many people ID has gone because we have dropped that column. Now you can see lot of comorbidity is having 226 null values, and cardiological pressure is having X, right? So there are different ways in which the null values can be filled using mean, mode, median, and then zeros, ones, or any specific value. Let's say any hypertension value cannot be filled up just like that. There is a standard value, with that you can fill. Okay, that is also possible. Here I have shown you how to fill this comorbidity value with a mean. Okay, understand, assuming that the average of the effect, that is defect history or the patient history, will be the same for all, and hence after filling up, you can see the comorbidity null values have gone out. Okay, similarly for all other values I am trying to fill a 0. Okay, now having done that, now your data set is ready for execution. Okay, now I am going to split it into training and testing data set. Okay, so before splitting that into training and testing data set, our duty is to first divide the data set into set of input attributes and output attribute, right? And hence xtrain will have set of input attributes. How many will have? Total of 17 columns is there as of now. So indexed with 0 to 16. So the columns with 0 to your what to say, the 15 will go for your input data set, the column at 16 will go for your output data set, okay, and hence it goes on. So this xtrain will be having that many number of columns. Actually here it should be 2, okay, and this y train, the 16th column if you take, you can see the shape which it has, okay, and then coming to training and test splitting, okay, now you have your input attributes followed by your output column. Now the entire data set of that 1704 rows is going to be splitted into training and testing data set. Actually in the repository test data set is separately given, but I have used splitted the same data set here. It is like the test size I have given is 0.2, which means training size is 0.8, which we are trying to split the data set into 80-20 ratio. You can try with different data sets to understand how the algorithm works or the model works. And if you print, you can see 80% of 10714 becomes the number of rows, okay, and this is how you can load the data set back. See, now that we have processed the entire data set, if you want to store it back for further analysis and your experience, you can store it back using 2CSV, okay. And then today I am applying only linear regression. So I have imported from sklearn the library using this linear model. So we are creating an object for linear regression. The name of the object is regressor. Regressor.fit_of. Okay, so how the system model has to that is experience and understand it is by using set of input values with the set of output value, right? So the input values are stored in x underscore train, y, the output values are stored in y underscore train. From where these comes, it is through this training testing split, okay. If you give the data set, it will give 4 different outputs: x train, y train, which is having the input and output values corresponding to your training data set, x test and y test corresponding to the input and output values of your testing data set, okay. So now this regressor.fit will try to create an equation called y is equal to m1 x1 plus m2 x2 and so on up to m15 x15, okay. So as such, if you have 16 input attributes, okay, plus the intercept bias of the system, okay, which we call it as intercept, which is c. Yeah. All the values you can print and you can see, and having done that, now our duty is to predict for the test data set, okay. How to do? Using this predict function, pass this x test. What is x test? It is nothing but the set of input variables with the testing values, right? Okay, having done, I just have shown one simple plot, okay, some 3D plot you can see. What I did is, I have drawn a scatter chart having the first, see, to a max of 3 combinations you can see x, y and z axis, right? So the z axis will always be our predicted value. X and y you can change and find out how it is distributing and how comes the error, okay? So x train of 0, 0 means your first column, 1 means your second column, z value is nothing but your y underscore train, okay? Similarly, the test also I have done. So x test, the first, same column 0 and 1, and where is the actual test values now? It is y underscore prediction, okay. That I have printed, and you can see more or less we got proper output, okay. So you can alternatively here also, instead of training, you can give, okay, here you can give test data, y is equal to test data if you are more interested in x underscore test. Here also, if it is test, you can see where and all the difference happens, okay. See, okay, so this is as per your testing data. This is as per the values that is predicted. You can see the more or less match, and hence we should expect a minimal error loss, okay. But there are differences which if you keenly observe, you can understand the differences, and that becomes your error, okay. Now, I just have drawn a bar chart between the age and then the infection probability. Okay, what is the number of people who has got infected. So it is almost between the age of 15 to 25. That's what the statistics says according to this data set. Okay, so that also you can do. Okay, and this is to perform normalization. If you want, you can perform normalization. Is generally performed to have for a better visualization. See, if the values are ranging too high, okay, you cannot visualize normally, and hence normalization can be applied. Okay, now this is the diagram after normalization of the same value. It is just for better understanding visualization. It won't change the that is proportionality in the value of a particular attribute. Okay, so having done all those things, the metrics which I have used. See, regression, we have three basic metrics. Okay, one is absolute error, mean squared error, and then root mean square error. Further, you can go for estimating R2 score. Okay, so all those things are available under the metrics library. Just we need to pass what are the original testing values for the output column, what is the predicted value, what is the name implicit. So how to calculate the error? It is nothing but the difference between your actual output and the predicted output. It is just a numerical difference. If you sum up everything, we say, and they take the average, that is mean absolute error. Okay, but the problem with that is always it is like the sign becomes the dominant parameter. We are not interested in the sign, whether actual is bigger or predicted is bigger. Rather, we are interested only in how much the absolute value, how much is bigger. How to do that? That's where is the mean squared error came into practice. Okay, you square a value, the sign will go off, right? So, and hence the actual difference between minus your predicted difference, square it to get the absolute value. Okay, so and hence you take the summation, divide by your total number of entities you have, that is mean squared error. Okay, now it may be more, right, because you already have squared and you have applied a operator over there. Okay, how to bring it back to your actual pavilion, that is root mean squared. You take a square root assuming that the values will bring back to the actual markings. So that's where mean root square error came into practice. It's all very simple rather than that. So looking at that, 5.9 is the error rate that I have achieved till now. And 5.9 it means like 100 minus this is the actual accuracy of my model. Okay, so without pre-processing, when we have done, it is around 60%. Okay, lot many pre-processing also due to time constraint I have restricted. So this is how we can take up a data set, pre-process it, visualize, and then apply a model according to the data you have and come out with an error metric. Okay. I hope I am done with my agenda today.